One of the main features that makes Python such a flexible language is that it's dynamically typed, meaning we don't have to specify the types of our variables when we assign them, and we can reassign the value of a variable to a different type. Dynamic typing makes Python flexible, but type errors result in runtime crashes. Let's take a look at an example. We define a function that adds two numbers, but we call the function with an integer and a string. This results in a type error since Python doesn't know how to add an int and string together. This error happens at runtime, meaning the program crashes when it runs, which is not good. Compare this to the same function written in Java. Since Java is statically typed, we have to specify the type of variables we define and parameters in functions. This is more boilerplate code, and we still get an error. But the difference is, this error happens at compile time, not at runtime. This means the program is never able to be ran. We must fix this error before running our code. Python has a library called typing that adds type hint support for functions and variables. Today, we'll learn how to use type hints effectively in our code. Type hints don't make Python a statically typed language like Java, but it helps make our code more readable and maintainable by clearly defining what types are expected. To enforce type hints, we can use a tool called mypy. MyPy is a static type checker for Python that analyzes the code and verifies if the type hints are being followed, which catches potential bugs before runtime. By combining type hints with mypy, we can achieve some of the benefits of a statically typed language, while still enjoying the flexibility of Python. We must add type hints before using mypy, so today we'll focus on the typing library, and we'll go over how to use mypy in another video. We'll start with a function with no type hints. To add type hints to the function arguments, we place the type of the variable after the variable name, separated by a colon. In this case, we're indicating that we expect name to be a string. We could do the same thing with quantity. Here, we're indicating that we expect quantity to be an integer. We also can indicate that price is an integer. The parameters of this function now have type hints. We can also indicate what we expect the function to return by adding an arrow after the function parameters, followed by the type of the data we are returning. In this case, we're indicating that we expect this function to return a tuple containing a string and an integer. We could also add type hints for individual variables within the function. To do this, we add a colon after the variable name, followed by the type of the variable. Adding type hints to a function doesn't change the behavior of the function. It makes it more readable for developers by indicating exactly what the function expects and what it should return. The bottom function is now able to be used in a static type checker, like mypy. We can add type hints for each of the basic data types, integer, boolean, string, and float, by adding a colon after the variable name, followed by the data type. We can combine the basic data types to add type hints to collections. To add type hints to a list, we add a colon after the variable name, followed by list, and the data type we expect the list to contain. We can indicate that the list has mixed types by separating the data types with a pipe character. In this case, we indicate that the list can contain integers or strings. To add type hints for a fixed length tuple, we exhaustively list each of the data types in order. And for tuples that are expected to grow, we add the data types we expect, followed by 3 dots. For dictionaries, we add the type of the key, followed by the type of the value. If our values can have different types, we again separate them with the pipe character. Finally, for sets of the same type, we just specify the type. Otherwise, we use the pipe character with each type we expect. What happens if our variable is potentially none? In this case, x can either be a string if condition is true, otherwise it's assigned to none. From what we just learned, you might expect we define the type to be a string or none. This is correct, but there's an easier way to do this. If we import the optional type, we could define the variable to be an optional of string. This means we expect x to either be a string or none. We should use optional if the variable is potentially none. What if we have a collection with a bunch of mixed types? In this case, we have a list of an integer, string, float, boolean, and then a list of integers. Instead of creating a complex type annotation to handle all the possible types, we can import the any type and annotate the variable with list of any. This simplifies the type annotation, but it signifies that the list could be of any type. So if we use this with mypy, type checking won't be enforced. Any should only be used with very dynamic types, like in this case, or unknown types. If you learned something, please consider following me on these other platforms. Thanks for watching.